Hi there, and welcome to this tutorial for motion matching for Unity. In this tutorial, we're going to look at how to use decouple controllers and what they are. Now, before we talk about what they are, we first need to talk about the two main ways that we move characters in games. One of those ways is root motion, and this character here is using full root motion. And the other way is through kinematic code-controlled movement. So we're basically telling the system move this amount, and it's very explicit. Now, what is root motion exactly? For those who don't know, root motion is when the animation actually drives the movement. Now, the benefit of root motion is that you get less foot sliding, the movement is more realistic. However, the bad side of root motion is that it can be unresponsive. And the less responsive your animations are, for example, the longer your animation takes to turn around, like this one here is pretty slow and unresponsive, the less responsive root motion is going to be. So you can fix it a little bit by just having more responsive animations, but there's still going to be some level of unresponsiveness. It takes time for a human to turn around, and that is realistic. You cannot have complete twitch controls and realistic movement at the same time. It's a cursed problem, it's an oxymoron. So a lot of people often ask me this, They want both twitch controls and really realistic animation, and I'm sorry, it's just not possible. But we can get somewhere in between. So that is root motion. So what exactly is decoupling? So decoupling is a technique where we can use code-controlled movement on a character controller and use root motion on the model and allow the model to stray just a little bit. I'm talking about 15 to 30 centimeters tops from the controller to help with foot sliding. This way, the character controller is controlled with code, and we still get a little bit more realism. There's still going to be some foot sliding, but it makes it a little bit better if you need more responsive animation. Or more responsive movement. Now, of course, it's going to completely depend on your game, which line you go down. You could go full root motion, you can go fully not root motion for something like a twitch shooter, and then you could go somewhere in between. A really famous game called Horizon Zero Dawn, 10 out of 10, uses a combination of root motion and code-controlled movement in different situations. And the decoupler is going to allow you to do that as well. So let's have a look at a decouple controller. And I'm just going to activate that guy and deactivate the other one. Now, these prefabs are available, so you can drag them in and have a look at them. I'm going to also change the camera to look at the new one. Now, I've actually turned the decoupling off. So this is what it's going to look like if your character is completely code controlled 100%. And you can see, particularly with these really slow animations, the feet are sliding all over the place, and it's not great. So I'll turn on gizmos, and you can see I'm controlling the character controller with code. It's very predictable, it's very smooth, but these animations in particular are pretty unresponsive, and it's just sliding all over the place. So let's do a few things. So here's my decouple, my MXM animation decoupler. This is the main component. I'll teach you how to set up the components for a decouple setup in a moment, but let's just have a look at some of the settings. So I'm going to allow it to decouple 0.3 meters from the controller, and you can see that the character is actually able to move a little bit off the controller center, and because of that, it's got a little bit of leeway so that it doesn't slide immediately. Obviously, it's going to still slide a bit, especially with such unresponsive animations, but it's slightly better. Now, if you had really responsive animations, this might be enough. You might even put it down to 0.15 or whatever suits your game. But in this particular case, where my animations are terribly unresponsive, I can do a few extra things. So one of those things is I can say, okay, I want you to turn root motion on when I'm not holding down on the stick. So this is for stops. And I'm pretty sure this is done in Horizon Zero Dawn. So if I activate this, when my character goes for a stop, the character controller is completely root motion controlled. And you can see that there. I get no foot sliding on the stops whatsoever. And if I turn it off, I'll show you that that turned off. You can see my character does move off the character controller. The next thing we can do is we can also say, hey, let's blend root motion with our own code controlled motion, depending on how, depending on if our character is facing in the direction we want to go. So if we have a look at this, if our character is facing the opposite direction that the controller is going, the sliding is obviously much worse. So the bigger that angle between the way that we're going and the character's the animation's facing direction, the more root motion we use, basically. And we have complete control over how much we use. So let's turn that on. Sorry, not that top one, that's root motion override. And we can say the minimum angle to blend, so only if it's greater than 30 degrees difference between the character's animation rotation and so the model's rotation and the direction we want to go. The maximum amount of root motion we're allowed to use, so 1 is 100%, you could set this lower. And then we have a curve, and this curve is basically going to be sampled depending on that angle, right? The angle between the way the model is facing and the way we're trying to go. So if it's like 180, we're going to have more root motion. If it's, only say 40%, it's going to be somewhere there. So while we're doing this, you can see we get a little bit more responsiveness. There's still a little bit of foot sliding. And this basically allows us to get the best of both worlds to a degree. And it's going to depend on your game exactly how much root motion you want to use and how much of your own movement you want to use. You might only want to do it for 180s, and you could set up that curve appropriately. So you can see now that when I'm doing 180 plants, I'm pretty much going full root motion until my character is almost all the way around. So these are the benefits of a decouple controller. The real main thing of a decouple controller is this, decoupling of the model from the character controller. However, I have added in these root motion options as well, because it allows you to balance your root motion and code-generated movement. So, how do we set this up? Let's make a copy of our normal controller and convert it into a decouple controller. Of course, you can find this prefab that's in the MXM demo and have a look at it yourself, but let's actually go and set it up. So I'm going to disable that one, and I'm going to copy the normal Kyle. So this is the normal Kyle without decoupling, so let's call it decouple tutorial, and let's activate him. And I'm also going to set him to be looked at by the camera. Where did he go? This one. Drag him in there, drag him in there. Okay, so let's have a look at it. So in the normal setup, everything is on the base layer. Now, I usually don't recommend this way of doing it, but you can do it if you're not decoupling. However, if you are decoupling, you have to have it in a different setup. So let's create an empty game object, and let's call this Robot Kyle. So let's just call this player, for example. And we can drag and drop our Robot Kyle that we had before onto here. Now we're going to have to remove all the character controller stuff from this. So let's remove the character controller, and it's dependent on, so there's a dependent script, so I have to remove that first. So the Unity controller wrapper will remove that. Let's remove the character controller. So we still need the MXM trajectory generator, we'll leave that. We need to remove the MXM root motion applicator. We keep the MXM animator. We can remove this input code. I'm going to remove the volt detector because we're not really talking about that stuff, and the locomotion speed ramp, because we're just trying to keep things simple. Those are just extra things. Okay, so now we've removed a whole bunch of those components, and there's one that we have to replace. So we had the MXM root motion applicator. Now we need to use the MXM decouple motion applicator. And this is basically a root motion applicator that's to be used specifically for decoupling. So now we can go to our player character. So now we've got this separation of model. This is the model, and this is the player. And we can add our character controller here. I'm going to set that up to 1. There's something funny here. I've got to actually reset this because our player is actually, I had it positioned funny. So let's put that down to 0. Yeah, that'll do fine. Okay, so I've just had to realign the that player. I didn't reset it. Okay, so that's all set up. Let's add in a Unity controller wrapper. So we've just shifted the character controller and controller wrapper to the player. We need to add now a MXM animation decoupler, and that's the script that I showed you before. And now, as far as MXM is concerned, we're pretty much set up. The only thing we have to do is go to our model, and we need to actually drag in the reference to our generic controller wrapper, which is, in this case, a Unity controller wrapper. We need to drag that into there, so that will work nicely. Okay, so we still need to make sure that our MXM animator root motion is set to root motion applicator. Now, but because we're using a decouple setup, it's going to only apply that to the model, and then the decoupler is going to do the clamping and all the other stuff. So I'm going to check on these buttons just to, I'll make a curve. Let's make one like that. Maximum of 100% root motion, starting at 15, 20%, that'll do. So there's only one thing missing now, and that is your own custom gameplay movement. Now, because we're not moving the character with root motion anymore, we can't really, we have to write our own, right? So it's got nothing to do with MXM anymore. We've basically got to write our own. Now, there is an example decouple movement control. This is literally a very, very simple example, and we'll go through it briefly. The only thing that we have to do when we do this is we need a function that updates our movement logic. And we need to make sure that in the MXM animation decoupler, we add that function. So let's go back here, and I'll go add a callback. So this is movement logic, and I'm going to drag the example decouple movement control, and we're going to find that function. In this case, the function that I've called is update movement logic. Now, this passes in a float, which is the delta time, and the reason for that is because you might be using a fixed update character controller, like kinematic character controller. So the decoupler will tell you what delta time to use in that update. So I've got update movement logic, and that's set. So whenever the decoupler says, hey, I need the movement logic to run, it's going to call a function on your movement script. So let's have a quick look at our movement script here. And I'm not going to go into too much detail, but I will go over a few things. We've got a reference to our generic controller wrapper, our trajectory generator, and our MXM animation decoupler. Keep in mind, you might not need all of that. In the awake function, we just get the components that we stored up here and cache them. And now the main thing is this logic, update movement logic. So this isn't a very big script, okay? And the main thing is this update movement logic, which we actually set a callback for from the decoupler to be called then, instead of with a monobehavior update function. So everything I tell you here is going to be my way of doing it for this particular case. You will have a different way of moving your character, and you'll see why in a moment. Though there is one or two functions that you do really need to understand here. So let's have a look. The first thing we do is I'm going to extract some motion from the trajectory generator. Now, why am I doing this? Okay, so my trajectory generator is already running a kind of motion logic, but it's running it several times per frame to get a future trajectory. Now I'm thinking, well, so that I can have my trajectory and my animation that's trying to match that trajectory be as close as possible to each other, I should probably move my character with the same logic. And instead of running it again, why don't I just extract that motion from the trajectory and use it again? So in this function here on the MXM trajectory generator, I'm extracting the motion at 0.3 seconds in the future. Now, you could use a smaller number, but I find that it's better to pick something like 0.3 seconds and then average it. So I'm picking the motion, and it actually returns a tuple with a vector 3, see move delta and angle delta. Now I'm basically taking that information and I'm converting it into move deltas. So here I'm just averaging it. I'm averaging the move delta and the angle delta from my trajectory generator. And then this is where the trick comes in. If you want to blend your movement with root motion, you will need to understand this function, and it's a function of the animation decoupler, and it's calculate root motion blending. So if we use the MXM animation decoupler .calculate root motion blending, we pass in our move delta. So this is our code generated movement. We pass in our angle delta, our code generated angular movement, and then we basically pass in a boolean that says if we actually have movement input on the stick. Okay, so my trajectory generator already tracks that, so that's why I'm using it here. You can have your own logic to determine if you have movement input. It's up to you. So I'm basically taking my motion that's done by custom gameplay logic, in my case, extracting it from the trajectory generator. You do not need to do this. You can do your own logic if you want and have your own move delta and own angle delta. Pass it into this function to blend the root motion based on your settings. Then all I'm doing is I'm adding gravity. Now, you can add your own gravity here in your own way. My animation decoupler already does it, so I can actually just change the Y of the move delta to equal calculate gravity move delta on the animation decoupler. That's again, I'm just doing it. You can do your own gravity here, no problem. And then I'm literally just telling my generic controller character to move. And that's it. That's all there really is to it. You can also tell it to rotate if you want, but I don't need my controller to rotate when my animation rotates separately. So very, very simple. It might look a bit funny because I'm extracting stuff and then I'm blending stuff. It's really not that complicated. Do your own movement logic, pass it in to be blended with root motion. The animation decoupler will do all the work with this function. Add your gravity if you want gravity, then move your generic controller wrapper. So this is the character controller wrapper move function. So that is it. That's all you need to know to set it up. Now, obviously, it's probably going to be easier if you just take this prefab and have a look at it and set up your own way. Now, there isn't a hard and fast rule of when to and when not to use decoupling. It is a gameplay decision. It's actually got nothing to do with MXM in terms of animation. If we think of animation, MXM as a animation generating system, this is more of a utility script, a utility to help you get the best of both code generated movement and root motion. So I hope this is clarified a bit to do with decouplers. Now, if you're using kinematic character controller, there is an integration for that, and I have both a normal setup character and a decouple setup character for kinematic character controller. So have a look at those because the setup is a little bit different. Any character controller that uses fixed update is a lot more complex to code for, and I've done that with KCC, but if you want to look at an example of how that's done to make your own for your own character controller or whatever, then have a look at that as well. Now, there's one more thing I want to point out. If you are using KCC or a fixed update controller, you're going to have to set your animator to animate physics. So that's one thing. And then on your decoupler, you're going to need to check this fixed update controller checkbox. And that's going to change the update order of your decoupler and all that. So it's going to work. So one last thing. Because of the way decoupling works, your events and animation warping is not going to work with a decoupler unless you override it completely with root motion. So when you're calling an event that needs to have movement, so for example, Kyle jumping up on top of this thing or jumping up there, and it's actually warping it so that the contacts hit exactly, you're going to have to turn on the root motion override, so this checkbox here, through code when you trigger the event so that it's completely root motion controlled and so that the warping is going to work. So that's just something you need to keep in mind of. Any warping is going to fail if you don't have that checked. All right, I think I've covered pretty much everything for decouplers. So thank you for watching, and I'll see you in the next video tutorials.